Okay, today, we're going to start on non-Mendelian genetics. So there are other ways to inherit traits other than Gregor Mendel's complete dominance. So we're going to first look at incomplete dominance and codominance. So the first one we'll look at is incomplete dominance. And in incomplete dominance, you have a trait that has two alleles. But when you get a heterozygous for these two alleles, so that means usually we're talking about one capital and one lowercase, instead of just seeing the dominant, you end up seeing a blended effect between the alleles of the parents. Now, this is different from complete dominance because neither allele in this case is completely dominant over the other. A couple examples we'll look at are snapdragon flower color, which we can see the variations there. We see some red and we see some pink and we see white. And then we'll also look at human hair texture, which can be straight, curly, or wavy. So first we'll look at the human hair texture. So since we're using um, a characteristic that does not have a dominant, one way to show the alleles is to use two different letters. So we will use C's for curly and S for straight. So if you have someone who has pretty curly hair, then you're going to have two capital C's. If you have somebody who has pretty straight hair, then you're going to have somebody who has two capital S's. And then working out the Punnett square is going to work out the way that it always does. So we're going to put one parent on the left, and remember to separate them because of the law of segregation, and one parent up top. Doesn't matter which one goes where. And now we'll just put them together. Box 1, CS. 2, CS. 3, CS. And 4, CS. When we look at the phenotypes, each of these are going to be wavy according to our key. So each of these are wavy, so that's 25, 50, 75, 100%. And then the genotype, of course, is 100% CS, which is heterozygous. So the wavy of the waviness, this blending, depends on how curly is the curly and how straight is the straight. Now, this is our F1 generation, so our first generation of kids. So since these are not pea plants, we cannot self-pollinate. So what we're going to do is we're going to take Hermione here, and we're going to marry her off to someone who also has wavy hair. And we'll see what we get in the grandkids. So again, there goes Hermione. There goes her husband. Box 1, big C, big C. Box 2, CS. 3, CS. And it doesn't matter which one goes first. It's just whatever pattern you start out with, just keep it. And the last one, SS. Now, if we're looking at the phenotype and the genotype, they're going to be very similar here, but we'll just focus on the phenotype. So our first box here is big C, big C. So that genotype is going to give us curly hair, and it's one box. So we've got 25% curly. Box 2 is C and an S, and according to our key, that means wavy. So we've got two boxes, so that's 50% wavy. And then box 4, we have two S's, and according to our key, that is straight. So 25% straight. And the way that our ratio works out is 1 to 2 to 1, which happens to be the same ratio as the genotype. Now, with this situation, make sure that you make a key so that you can keep up with what you're dealing with here. But one thing that I would make sure that I would stay away from is using lowercase letters, because lowercase letters to us means recessive. So you can use two different letters. You could use the lowercase, or sometimes people will use, and I tend to use this myself, is a C and let's say a C prime to represent the straight. And for the C prime, all that you would have to do is to put a little apostrophe beside of it. Okay, the next thing I want you to do is to practice this. So you can practice this on your own paper. And what you're going to be practicing with now is with the snapdragons, which are flowers. And for the flower color, red is going to be represented by a capital R. White is going to be represented by a capital W. Remember, stay away from those lower cases. Purebred is the same thing as saying homozygous. So we're saying in snapdragons, flower color is incompletely dominant. Form a cross between a homozygous red flower, big R, and a homozygous white flower, big W. And then what will be the genotypes and phenotypes of the offspring? So whatever you get in this box. Then for the second part of this, perform a cross between two members of the F1 generation. So take two of these guys from here and just drop them down. And then what will be the genotypes and phenotypes of the offspring? So basically that's your F2 generation. So once you've done that, then we'll go over this.